solve y into 2x minus y plus 1 into dx plus x into 3x minus 4y plus 3 into dy, which is equal to 0. Observe carefully, this is an equation of the form m dx plus n dy, which is equal to 0. Here multiply x inside the bracket and y inside the bracket and write it as 2xy minus y into y is y square plus y into dx plus 3x square minus 4xy plus 3x into dy, which is equal to 0. Hence, we can conclude that the differential equation is of the form m dx plus n dy, which is equal to 0. Next step, find m and n value. That is, m value is this 2xy minus y square plus y and n is 3x square minus 4xy plus 3x. After identifying m and n value, next step we have to find del m by del y and del n by del x. That is, del m by del y is partial derivative of m with respect to y. Here 2x is constant, take as it is, into differentiation of y is 1 minus here differentiation of y square is 2y plus differentiation of y is 1. This is our del m by del y value. Similarly, del n by del x is partial derivative of n with respect to x. So 3 is constant, take as it is, into differentiation of x square is 2x, that is 3 into 2 is 6x, minus 4y is constant, take as it is, into differentiation of x is 1, that is minus 4y, plus 3 is constant, take as it is, into differentiation of x is 1. Hence we get del n by del x value as 6x minus 4y plus 3. If the given differential equation is exact differential equation, then we obtain the value del m by del y, which is equal to del n by del x. But here del m by del y value is 2x minus 2y plus 1. Del n by del x value is 6x minus 4y plus 3. Hence, we can conclude that del m by del y value which is not equal to del n by del x value. Therefore, the given differential equation is not an exact differential equation. Once we conclude the given differential equation is not an exact differential equation, our aim is to reduce this non-exact differential equation to exact differential equation. For that, first find del m by del y minus del n by del x value, that is difference of del m by del y and del n by del x. Here del m by del y is 2x minus 2y plus 1 minus of del n by del x is 6x minus 4y plus 3. Hence we get 2x minus 6x is minus 4x. Here minus 2y, here minus into minus, plus 4y is plus 2y, plus 1 minus 3 is minus 2. This is our del m by del y minus del n by del x. After obtaining del m by del y minus del n by del x, next procedure is this difference of del m by del y minus del n by del x is close to either m or n value. So identify carefully, this is of the form minus 4x plus 2y minus 2. Hence, if we take minus 2 as common in here, we get as here minus 2 common means the remaining is 2x minus y plus 1. Now, observe that the difference del m by del y minus del n by del x is close to the value m value is y into 2x minus y plus 1, or you can take this also m value, but you can take this value so that you can cancel easily. Here also del m by del y value is minus 2 into 2x minus y plus 1. So this value is close to m, so that we have to multiply this del m by del y minus del n by del x with 1 by m. That is the next step. Therefore 1 by m into del m by del y minus del n by del x value, which is equal to here 1 by m is this y into 2x minus y plus 1 into here del m by del y minus del n by del x value is minus 2 into 2x minus y plus 1. Now we can cancel this term. The remaining is minus 2 by y. Here this is the value of 1 by m into del m by del y minus del n by del x. Observe carefully, this is some function which contain only y. So we can take this as a g of y, that is 1 by m into del m by del y minus del n by del x value, which is equal to g of y. If g of y is a case, then to find the integrating factor, the formula is given by exponential power of minus integral of g of y into dy. Here identifying this values contains only x or only y, we have to take the integrating factor. If it is the function contains only x, means the integrating factor is exponential power integral of f of x into dx. But here is a function which contains only y. Therefore, the integrating factor is exponential power minus integral of g of y into dy. Substitute g of y value as minus 2 by y and simplify, we get as exponential power of minus of integral of minus 2 by y into dy. Here minus to minus plus, take 2 outside the integral, that is constant term. Therefore, we get as exponential power of 2 into integral of 1 by y into dy. This is of the form integral of 1 by x into dx. We know that integration of 1 by x into dx is log x, because integration and differentiation of both are inversely proportional to each other. That is, differentiation of log x is 1 by x. Similarly, integration of 1 by x is log x. Therefore, here we have in the place of x we have y. Therefore, we get as exponential power of 2 into, here this is integration of 1 by y into dy is log y. This is of the form n log m. We know that n log m can be written as log m power n. Therefore, we get as exponential power of log of y square. Hence, here exponential power of log of y square can be written as y square. Simply y square. Here exponential log gets cancelled. Therefore, we get an integrating factor as y square. After obtaining the integrating factor, what's the next step? Multiply this integrating factor to the given differential equation. We get as, here the given differential equation is 2xy minus y square plus y into dx plus 3y square minus 4xy plus 3x into dy, which is equal to 0. Multiply this equation with y square. We get as, here 2x into y is y cube minus y square into y square is y power 4 plus y square into y is y cube into dx plus 3x square into y square is 3x square y square minus 4xy into y square is 4x y cube plus 3x into y square is 3x y square into dy, which is equal to 0. Now, after multiplying this integrating factor with the given differential equation, then we can easily find the exact differential equation, because the equation reduces to exact differential equation. Verify that first. Here, this is of the form m dx plus n dy, which is equal to 0. Therefore, we can conclude that here m dash is 2xy cube minus y power 4 plus y cube. Similarly, n dash is 3x square y square minus 4xy cube plus 3xy square. So, after obtaining m dash and n dash, procedure as before for exact differential equation. Del m dash by del y, that is differentiation of m dash partially with respect to y. We get as, here 2x is constant, take as it is, into differentiation of y cube is 3y square. So 3 into 2 is 6xy square minus y power 4 differentiation is 4 into y cube plus y cube differentiation is 3 into y square. This is our del m dash by del y. Similarly, find del n dash by del x. Therefore, that is partial derivative of n dash with respect to x. Here 3y square is constant, take as it is, into differentiation of x square is 2x. Hence, we get 3 into 2 is 6xy square minus 4y cube is constant, take as it is, into differentiation of x is 1, hence we get minus 4y cube plus 3y square is constant, take as it is, into differentiation of x is 1, hence we get 3y square. Observe carefully, here del m dash by del y value is 6xy square minus 4y cube plus 3y square. Del n dash by del x is 6xy square minus 4y cube plus 3y square. Both are same. Therefore, we can conclude that del m dash by del y, which is equal to del n dash by del x. This shows that the differential equation is exact differential equation. Once we find the exact differential equation, the solution of the exact differential equation is given by integral of m dash of x comma y of dx plus integral of terms which does not contains x in n dash into dy, which is equal to 0. This is a solution for exact differential equation. In previous videos, the exact differential equation solution is given by integral of m of dx plus integral of term which does not contain x in n into dy, which is equal to 0. But we have in this problem here m dash and n dash value. We know that from the reduced exact differential equation, m dash is 2x y cube minus y power 4 plus y cube. N dash is 3x square y square minus 4x y cube plus 3x y square. So substituting values here, we get as, here we have integral of m dash of x comma y of dx. have to substitute m dash value over here, that is 3xy cube minus y power 4 plus y cube into dx, plus integral of terms which does not contain x in n dash. Here this is an n dash which contains here also x, here also x, here also x term. So in the place of this we have to substitute 0 into dy which is equal to 0. Here this value becomes 0. Hence expanding the integration we get as, here 2 into y cube is constant, take as it is. Here integration of x with respect to x is x square by 2 minus y power 4 is constant, take as it is, into here we have remaining is 1. Integral of 1 dx is x plus y cube is constant, take as it is, into here also 1, integration of 1 is x which is equal to some arbitrary constant c. Here 2 gets cancelled, remaining is x square y cube minus x y power 4 plus x into y cube which is equal to c. This is the solution for the given differential equation. This completes the problem.